Git is one of the most popular version control systems, widely used for tracking changes in code, collaborating on projects, and maintaining a clean development workflow. Below is a comprehensive guide covering everything you need to know about Git, from its fundamentals to more advanced features. What is Git? Git is a distributed version control system, DVCS, that allows multiple developers to work on a project simultaneously without overriding each other's changes. Git tracks changes to files over time, enabling you to revert to earlier versions, view the history of the project, and collaborate seamlessly with others. Key features. Distributed. Every developer has a complete copy of the project's history. Efficient. Git compresses and stores data efficiently. Flexible. Git supports branching, merging, and rebasing, making it highly flexible for various workflows. Secure. Git uses cryptographic methods to ensure that the history is tamper-proof. Key terminologies. Before diving into Git commands and usage, it's essential to understand the key terminologies. Repository, repo. A Git repository is where your code and its entire version history live. Repos can be local, on your computer, or remote, hosted on platforms like GitHub. Commit. A snapshot of changes in your project. Each commit is accompanied by a message explaining the changes. Branch. A branch is an independent line of development. The default branch is called main or master. Merge. Combining changes from one branch into another. Pull request, PR. A mechanism to propose merging changes into a project's main branch. Clone. A copy of a Git repository that resides on your local machine. Push/pull. Pushing sends your commits to a remote repository, while pulling fetches changes from it. Staging area. A place to gather changes before committing them. This allows you to prepare a clean, structured commit. Setting up Git. Install Git, Linux, sudo apt get install Git, Mac OS. Install via Homebrew, brew install Git, Windows. Download from Git official website, https://git-sem.com. Configure Git after installing Git. Configure it by setting up your user details. Git config, global user.name, your name, Git config, global user.email, your _email at example.com. Basic Git workflow. The Git workflow typically involves 3 stages. 1. Working directory, where your files are created or modified. 2. Staging area, where changes are prepared, staged, for committing. 3. Repository, where the committed changes are saved step by step. Initialize a Git repository. Git init. Check the status of your repo. Git status, stage files. Git add to file name, stage, specific file. Git add. Stage all modified files. Commit the staged files. Git commit, your descriptive commit message. View commit history. Git log. Push your changes to a remote repository. Git push origin, branch name. 5. Branching and merging. Creating a new branch. Branches allow you to work on different features or bug fixes without affecting the main code base. Git branch to branch name. Create a new branch. Git checkout, branch name. Switch to the new branch. Alternatively, you can create and switch in one command. Git checkout, branch name. Merging branches. When you're done working on a feature, you can merge the branch back into main or master. 1. Switch to the branch where you want to merge the changes, e.g., main. Git checkout main. 2. Merge the feature branch. Git merge a branch name. Working with remote repositories, Git allows you to sync your local repository with a remote one hosted on platforms like GitHub, GitLab, or Bitbucket. Connecting to a remote repository to clone a repository from a remote source. Git clone, repository URL, push changes to remote to send local commits to a remote repository. Git push origin, branch name, pull changes from remote to fetch and integrate changes from the remote repository into your local branch. Git pull origin, branch name, Git collaboration, and pull requests, PRs, are used to notify others about changes you've pushed to a repository and request that they be merged into a certain branch, e.g., main. Creating a pull request, push your branch to a remote repository. On platforms like GitHub, create a PR by selecting your branch and describing the changes. Code review. PRs are often followed by a code review where team members review the changes and suggest improvements. Resolving conflicts. Conflicts occur when 2 branches have changes to the same part of a file. To resolve them, Git will mark the conflict. Head code from your branch code from other branch name. Manually edit the file to keep or combine the desired changes. Stage the resolve file. Git add a file name. Commit the resolution. Git commit reverting and resetting. Revert a commit to undo a specific commit without altering the commit history. Git revert, commit hash. Reset to a previous commit to reset your branch to a previous state. Git reset, hard, commit hash. Be cautious, as hard deletes changes that are not committed. Stashing changes. If you want to save uncommitted changes temporarily and come back to them later. Git stash to retrieve stash changes. Git stash pop tagging. Tags are used to mark specific points in the commit history, often to denote versions. Creating a tag. Git tag version 1.0.0, pushing tags to the remote. Git push origin version 1.0.0. Git ignore to prevent certain files, e.g., config files, build artifacts, from being tracked by Git. You can add them to a.gitignore file. Sample.gitignore. Ignore no nodules / ignore Python compiled files starred. PYC rebase. Rebasing moves or combines a series of commits to another base tip. Rebase your feature branch to include the latest commits from main. Git checkout, feature branch, Git rebase. Main working with submodules. Submodules allow you to include one Git repository inside another as a subdirectory. Adding a submodule. Git submodule add repository URL path. Do best practices. Commit frequently with meaningful messages. Use branches for features and bug fixes. Regularly pull changes from the main branch to keep your branch updated. Write good commit messages that explain why a change was made. Keep your commits atomic. Each commit should focus on a single change. Use tags to mark releases or major milestones. Conclusion. Mastering Git is crucial for developers, especially when collaborating on large projects. Start by familiarizing yourself with basic commands, then gradually explore advanced features like branching, rebasing, and working with remote repositories. With practice, Git will become an essential tool in your development workflow.